Magnets have a field around them. A field is a region of space around something where a force can act. And around this magnet there is currently a field which is exerting a force on anything which is made of a magnetic material. Now, we can't see this field as it's invisible, but we can show its effects by using iron filings. Now, iron filings are just little pieces of iron, and iron is a magnetic material. It will attract to a magnet. I'm going to place this magnet between these whiteboards so that I've got a nice flat surface. I'm going to place this piece of paper over the magnet. And all I'm going to do is sprinkle the iron filings over this piece of paper, and the magnetic field around the magnet will influence how these iron filings arrange themselves. Let's look at what happens. Now what you can see is the magnetic field pattern. You can see the iron filings seem to be arranging themselves in lines, moving from one pole of the magnet to the other. This is the magnetic field pattern. Now what I'm going to do is place a piece of transparent plastic over the top of our pattern, and I'm going to just outline how these iron filings appear to have arranged themselves. This which I've just drawn is the magnetic field pattern. The magnet is just sat here. You can see the poles of the magnet have attracted a great many iron filings. That's these areas here where the iron filings have concentrated. And then the field pattern seems to be moving out from these two poles to surround the magnet. And here's how the magnetic field pattern looks when the magnet's present. So it appears that we have these field lines moving from one pole to the other. But which direction are they moving? In order to work that out, we use a plotting compass. Now the plotting compass basically contains a tiny magnet inside it. You can see the red point there is pointing towards north. North in this instance is in that direction. So no matter which way I try and turn the compass, the magnet inside will always face the direction of the Earth's magnetic field. If we place that next to a magnet, you'll notice that the plotting compass, its direction changes depending where it is around the magnet. We can work out the direction of the magnetic field using that compass. So the north pole of any magnet will always attract to the south pole of another. Here we have the south pole of this magnet. It's attracting to the north pole of the plotting compass. You can see there the little red arrow points towards the blue. So we can use this to actually plot the direction of the magnetic field. So we're going to draw it on paper using a pencil. In order to do this, the first thing I'm going to do is draw around my magnet, just so that I still have the image when I take the magnet away. Next, I'm going to choose a point near one of the poles. I'm going to start with the north pole, and I'm going to draw a little dot next to the magnet. I need to align my compass so that the needle of the compass is pointing at that point there. And where the arrow of the compass points, I am going to draw another dot. I'm going to zoom in so you can see that a bit clearer. So here you can see the point is pointing at that position there. What I now do is move my compass along and make it so that the tail of the compass now touches that new point. There, you can see the tail of the compass is pointing at that dot. And I repeat the process. I put a dot where the arrow is pointing, and then what I need to do is move the compass so its tail now points at that new dot. And I repeat this process over and over again until I get to the edge of the paper. Now the arrow tells us the direction the magnetic field is facing. You can see here the red point of the compass is pointing away. So what we do is we join our dots and we show it's pointing away. As I move along, you can see while it's next to the north pole, the arrow of the compass is always pointing away in this direction. So we can join these dots up and continue the pattern. So what you can see is the magnetic field points away from the north pole of our bar magnet and towards the south pole of our magnet. We can repeat this in different positions. I'm going to speed the video up so you can see that happen much quicker. So what you can see now is the magnetic field pattern and the direction of the magnetic field lines around the bar magnet. If we compare the shape of that to this, you'll see that it has almost the identical shape. Now obviously I've not drawn as many lines on this one. I could have spent more time drawing more and more points, but you'll see that the pattern of both seems to be the same. The important thing in both of these pictures is these magnetic field lines never cross over. In both of these, the field lines do not cross. And the magnetic field always goes from the North Pole, which was the red side of the magnet, to the South Pole. The arrows will always move from north to south. Another important thing to realize is where the lines are closest together, that's where the magnet is strongest. So you can see here there are lots of lines in this area. Similarly, on this picture, there's lots of lines close together here, but as they move farther away from the magnet, they begin to spread out. In the middle of the magnet, there's very few lines at all. Where there's less density of these lines, where there are less lines all cluttered together, that's where it's weaker. So it's strong here where there are many lines cluttered together. Here you can see it gets weaker the further out you move. Similarly here, the further out you move from the magnet, the weaker the field because there are less lines cluttered together. We call that the magnetic flux density. So the important things to remember: close together field lines means a strong magnetic field. Further apart lines means a weaker magnetic field. The magnetic field lines also always move from the north to the south at all times. Always away from the north towards the south. And these magnetic field lines, they must never ever cross over. If they cross over, you're going to lose marks in your assessment.